And always make sure you double check your work, make sure you add up all your voltage drops, make sure it equals up to the source voltage. Take a look at it. So what do we get for our total resistance then?
600.
Yeah, make sure you get your 600 ohms. And then so what did you get for R4 was 330 ohms. And what did you get for voltage drop?
13.2.
13.2 volts. Okay, and R3 was 82 ohms. 3.280 volts. Okay, and our R2 was 68 ohms, and that dropped to how much?
2.720.
2.27.
7.2.
7.2.
Yeah, sorry.
And R1 was 120 ohms, and that one dropped
4.8.
And if we added up all our voltage drops, and it came up to our 24 volts. Okay, good. All right, so then what did we get? What did you get for test point A to G then?
Positive 7.52 volts.
Positive 7.52 volts. Okay, how about B to G?
Positive 2.720 volts.
Okay, and then our voltage of C to G.
3.280 volts.
Say one more time, Jeff.
Positive 3.280 volts.
Negative. So it should be negative.
Yeah. Oh yeah.
Negative 3.280 volts. Okay. Yeah, watch your polarities, and then test point D then.
Negative 16.48.
Negative 13.
What was it? Negative 16.48.
Because it's to G, C, and 2.
Okay.
I'm going to add the 13.2 and the 3.2.
All right, then.
Okay, yeah.
And then what would I get from test point? From just test point D, what would I get?
Negative 16.48.
Yep, I would get my negative 16.48 volts. It's the same as my D to G. I just didn't put my reference indicator, so then they can assume that it's going to ground, which is the same as my VDG there. So you should get a negative 16.48 volts. All right. So not too tough. You just have to make sure you watch your polarities in your curve paths.
How you
You just
add.
add them up algebraically. So you know, if it's either negative or positive. So when I'm saying that I add them up algebraically, let's see what would be a good one here. Let's go to, so I'm going to say from VB to D. So I'll just kind of spell it out here so if anyone's having a hard time understanding what I'm saying by algebraically. So when I say VBD, my red lead's going to go where? D. My black lead's going to go where? D. So when I'm algebraically adding them up, what I'm just going to say is that when I come in, I'm going to go, my first sign is negative 4.8 volts. So then I'm going a negative 4.8 volts plus a positive 24 volts. So then if I add a negative 4.8 volts to a positive 24 volts, then I'm going to get my, what am I going to get? Yeah, so I should get a positive 19.2 volts. So I'm just algebraically adding them up. So if I was putting it into my calculator, if I don't want to use my calculator, I don't want to use my minus sign, I want to use my negative sign. So on your calculator on the bottom, right underneath your number 3, for myself I would go ahead and I would hit 4.8 and hit my negate button, make it negative, and then I hit my positive sign, for my addition sign, which is on the right hand side. Then a positive 24.00 volts, and I hit equals, and I get a positive 19.2 volts. And then make sure that you put the polarity, make sure you put the positive sign on there, and your units. Okay? So we're just algebraically adding them up. All right. So I'll let you do the rest on your own. If you have any questions, let me know. Or if you have any questions, let me know. Yeah.
Before we go over 4-42.
4-42?
Nah, 44.
5.
Oh, yeah. All right, let's go, see if there's...
My only question is, what do you do when the voltage drops and don't add up to the full voltage?
Then you did something wrong.
Well, if you round it to the 4 digits.
Oh, did you get like, for example, for example, so on 4-42,
Yeah.
you got, what did you get?
95.23 for the voltage.
Oh, yeah, that's way too low. Now if you had like 99.9 volts or something like that, that's okay, but 95, that's too low. Yep. Yeah, that one's too low.
Yeah, because you're going to take your total current and multiply all your voltage drop.
Nah, we're not using current.
Total current.
No, we don't use current.
Well, that's one way to double check.
It is, but, well, since we know that, so let's just go ahead and let's just figure out the voltage drop here. All right, so let's find the voltage drops across each one of these components here. Did you? Read the number wrong? Your resistance total is wrong? Yeah. It should always equal up, you know. It should always equal up to your 100 volts, and that's why we always double check our words. So make sure you double check your words. All right, anyone feel pretty confident in the voltage dividers and test points?
Can we go over 4-44?
4-44? All right. Now, all right, let's do it. All right, so. Look at the nice guy I am. I'm even straight-lined it for you already. All right, take off. All right, so let's go ahead and, so the first thing as we talked about yesterday when we got two power supplies, first we have to identify whether if they're series aiding or opposing, right? So are they series aiding or opposing?
Aiding.
Aiding. And is my current going clockwise or counterclockwise?
Counterclockwise.
Counterclockwise, so I got it. So my current's going to be going through this way. Okay, and so since they're series aiding, my source voltage is going to be how much?
18 volts.
18 volts. Okay? My total resistance is going to equal what? So I'm going to add up just all my resistors in series, and I'm going to get what for total resistance?
6K.
6K?
Yep.
Okay? So now we just need to find our voltage drops across each one. So what's my voltage drop across R1?
3 volts.
3 volts. And R1 is that 1 kilo ohm?
Yep.
Okay, R2 is 1.8.
Yep. 1.2 is the next one.
1.2 kilo ohms.
And then 2.
Okay, so then my voltage drop across R2 is going to be what? 5.4 volts. And D3, 3.6 volts. And D4, 6 volts. And if I add those all up, do I get 18 volts?
Yes.
Okay. All right, so then we want to do our test points. So my first one is going to be from BAG. So where does my red lead go? A. My black lead's going to go where?
G.
G, right here. So all I have to do is just algebraically add it up, bring my red lead over. First sign of T is going to be a positive.